The work done in blowing a soap bubble of radius r is W. The work done in making a bubble of radius 2r from the same soap solution is 2W, 4W, W by 4 or W by 2. Now we know that the formula for work done W is equal to 2T into 2 pi r square. Now here for the radius r work done is W, so this is W for radius r, which is equal to 8 pi r square T. Now the work done in making a bubble of radius 2r, therefore W1 will be equal to 2T into 4 pi and radius will become 2r, which is 2r the whole square, which is equal to 8 pi T 4r square, which is equal to 8. We can take 4 common and we'll get 8 pi r square T, which is 4 into W. Therefore here the correct answer will be option B. The two arms of a vertical U-tube have internal radii of 0.4 cm and 0.8 cm respectively. The tube contains water. What is the difference in the surface level of water in the two arms? Here the surface tension of the water is given as 70 into 10 raised to minus 3 Newton per meter. Now it will be whether A 0.7 millimeters or 1.785 millimeters or 3.785 millimeters or 5 millimeters. Now we know that the h or the height is given by the formula 2t cos theta upon r rho g. But for water, since the solution given is water, for water cos theta is equal to 1 and rho is also equal to 1. Therefore, the difference in the height in the water level is 2t upon g into 1 upon r1 minus 1 upon r2. Therefore, on substituting the values of t as 17 10 to minus 3, r1 and r2 as 0.4 and 0.8, and g as 10, we'll get the answer as 1.785 millimeters. Therefore, here the correct answer is option B. A capillary tube of radius 1 millimeter is immersed in water. The mass of water rising in the capillary tube is m. If the radius of the capillary tube is doubled, then the mass of water that rises in the capillary tube will be m by 2, 2m, 3m, and m. Now, we know that the radius and the height is related by the formula h is inversely proportional to the radius. Therefore, h2 upon h1 will be equal to r1 upon r2, which is equal to half. Therefore, the mass is given by the formula m is equal to pi r square h1 into rho. Therefore, m dash is equal to pi, this is m second for h2, 2r the whole square into h2 into rho. Therefore, m dash upon m will be equal to 2r upon r the whole square into h2 upon h1, which will be equal to 4 into half, which is equal to 2. Therefore, m dash will be 2m. Therefore, here the correct answer is option B. Capillary tube having 1 millimeter and 2.5 millimeter as internal and external radii hangs vertically from the arm of a balance. The lower end of the tube just touches a liquid of surface tension 40 dyne per centimeter. If the angle of contact is 0, the change in weight due to the surface tension is, here are the options. Now we know that surface tension T is given by the formula T is equal to F upon L. Therefore, F will be equal to T into L, which is equal to T into 2 pi into R1 plus R2, which is equal to, therefore F will be equal to 40 into 2 into 22 by 7 into 0.1 plus 0.25, which is equal to 88 dynes, which on converting into newtons will give as 8.8 into 10 raised to minus 4 newtons. Therefore, here the correct answer will be option B. Two vertical parallel glass plates separated by 0.5 millimeter are kept in water. The surface tension of water is 7 into 10 raised to minus 2 Newton per meter. How high will the water rise between the plates? Here we are told to use G as 10 meter per second square. Now, the surface tension is given by the formula T is equal to R into H into rho into G upon 2 cos theta. Now we want to know how high the water will rise. Therefore, we need to find out the height. Therefore, H is equal to 2t cos theta upon R into rho into G. Now, since it is water, we know that the cos theta of water is always 1. and the R is equal to D is 0.5 into 10 raised to minus 3. Therefore, on substituting these values, we'll get the answer as H is equal to 2.8 centimeter. This is how much the water rises. Therefore, the correct answer will be option C. Two capillary tubes P and Q are dipped in water. The height of water level in the capillary P is 2 by 3. The height in capillary Q is 2 by 3 times the height in capillary Q. The ratio of their diameter is, here are the options. Now we know that the height and the radius are related by H is inversely proportional to R. Therefore, HP, which is the height of the tube P upon HQ, is equal to RQ upon RP. Therefore, HP RP will be equal to RQ HQ. Therefore, RP is equal to 2 by 3 into 2 by 3 HQ is equal to RQ into HQ. Therefore, HQ and HQ will get cancelled. Therefore, we'll get RP upon RQ is equal to 3 by 2. Therefore, here the correct answer will be 3:2, which is option A. Of water is formed between two straight parallel wires, each of length 10 centimeter and separated by 4 millimeter. How much work should be done to increase their separation by 1 millimeter while still maintaining their parallelism? Here the surface tension T is given by 7.5 into 10 raised to minus 2 Newton per meter. Now the work done will be given by 2 into T into dA. We take 2 because surface tension forms two spaces. Therefore, on substituting the values, 2 into 7.5 into 10 raised to minus 2 into the area, which is 10 into 10 raised to minus 2 into 1 into 10 raised to minus 3, which will be equal to 15 into 10 raised to minus 2 into 10 raised to minus 4, which is 1.5 into 10 raised to minus 5 joules. Therefore, here the correct answer will be option C. What is the change in surface energy when a mercury drop of radius r splits up into 1000 droplets of radius small r? The surface tension of mercury is given as T. Either it is 8 pi r square T, 16 pi r square T, 24 pi r square T, or 36 pi r square T. Now we know that the volume for one mercury drop is 4 upon 3 into pi capital R cube. Now this is split into 1000 droplets of radius small r, which will be equal to 1000 into 4 by 3 into pi into small r cube. Therefore, we'll get small r is equal to r upon 10. Therefore, now the change in the surface energy dE is given by T into 4 pi small r square into 1000 minus 4 pi into capital R square, which is 4 pi T 1000 r square upon 100. We'll substitute the value of small r as r by 10 minus 4 minus, yes, 4 pi is taken outside, r square. Therefore, on calculator we get as 9r square into 4 pi t, which is equal to 36 pi r square t. Therefore, here the correct answer will be option D. Water rises up to a height of 5 centimeter in a capillary tube of radius 2 millimeter. What is the radius of the capillary tube if the water rises up to a height of 10 centimeter in another capillary? It is either A 4 millimeters, 1 millimeters, 3 millimeters, and 1 centimeter. Now we know that the height and the radius are related by h is inversely proportional to r. Therefore, h1 is inversely proportional to r1. Since there are two heights then data given, therefore h2 will be inversely proportional to 1 by r2. Therefore, their ratio will be h1 upon h2 will be r2 upon r1. Therefore, h1 r1 will be equal to h2 r2. Therefore, we need to find the radius of the second time. Therefore, r2 is equal to h1 r1 upon h2, which is 5 into 0.2 upon 10, which is equal to 0.1 centimeter or 1 millimeters. Therefore, here the correct answer will be option B. A spherical water drop of radius capital R is split up into 8 equal droplets. If T is the surface tension of water, then the work done in this process is either 4 pi r square T, 8 pi r square T, 3 pi r square T, or 2 pi r square T. Now, for a water drop, the work done W is equal to 4 pi into R square into T. Therefore, since the volume is 4 pi R into R cube and it is split up into 8 equal droplets, let's take that the droplets have a small radius R. Therefore, 4 by 3 pi into small r cube into 8. Therefore, the small r will be equal to the original water droplet's radius upon 2. Therefore, the change in the area dA will be given by 4 pi r square into 8 minus 4 pi into capital R square. Therefore, dA will be equal to 4 pi common 8r square minus r square, which will be equal to 4 pi into r square. Therefore, now the change in energy will be given by dE is given by T into dA, which is equal to 4 pi r square T. Therefore, here the correct answer will be option A. Two spherical soap bubbles of radii R1 and R2 coalesce under isothermal condition. What is the resultant radius? Is it either R1 plus R2, R1 plus R2 upon 2, R1 square plus R2 square raised to half, or R1 plus R2 upon R1 into R2? Now, under isothermal conditions, total energy remains constant. Therefore, 8 pi r1 square into t plus 8 pi r2 square into t will be equal to 8 pi capital R square into t. Therefore, r1 square plus r2 square will be equal to capital R square. Therefore, r will be equal to r1 square plus r2 square raised to half. Therefore, here the correct answer will be option C. When the radius of a soap bubble is increased from 1 upon root pi centimeters to 2 upon root pi centimeter, the work done is 720 ergs. The surface tension of soap solution is either 30 dyne per centimeter, 20 dyne per centimeter, 15 dyne per centimeter, or 40 dyne per centimeter. Now we know that the work done W is given by the formula 2T into 4 pi R2 square minus 4 pi R1 square. Therefore, the work done is given as 720. Therefore, 720 will be equal to 2 into t. We have to find the t. 4 pi into 4 upon pi minus 4 pi into 1 upon pi. Therefore, 720 will be equal to 2t into 12. Therefore, t will be equal to 30 dyne per centimeter. Therefore, the correct answer will be option A. Work done in increasing the size of a soap film from 10 centimeter into 6 centimeter to 10 centimeter into 11 centimeter is 3 into 10 raised to minus 4 joules. What is the surface tension of the soap film? Now here are the given options. Now we all know that surface tension is given by the formula the work done upon change in the area. Therefore the work done will be 3 into 10 raised to minus 4, and the area, that change in the area is 2 into 10 minus 60, 110 minus 60 into 10 raised to minus 4. Therefore, on calculating, we'll get the answer as 3 into 10 raised to minus 2 Newton per meter. Therefore, the correct answer here is option C. What is the force required to take away a flat circular plate of radius 2 cm from the surface of water? Here T is given as 17 to 10 to minus 3 Newton per meter, and we can use the value of pi as 22 by 7. Now we know that the force required is given by T into L, which will be equal to 2 pi R into T. Therefore, 2 into 22 upon 7 into 2 into 10 raised to minus 2 meters into tension, which is given as 70 into 10 raised to minus 3. Therefore, on calculating all of this, we'll get the answer as, first we can remove 7 and we can make this as 10. So, on calculating, we'll get the answer as 44 into 2 into 10 raised to minus 2 into 10 raised to minus 2, which will be equal to 88 into 10 raised to minus 4, which is equal to 8.8 into 10 raised to minus 3 newtons. Therefore, here the correct answer will be option C. Liquid rises to a height of 3.3 centimeter in a capillary tube of radius small r. If the radius of the capillary tube is made 0.75 into times small r, then the height to which the liquid will rise in the capillary is 3.3 centimeter, 2.2 centimeter, 4.4 centimeter, or 1.65 centimeter. Now we know that the height is inversely relational to r. Therefore, h1 upon h2 will be given as r2 upon r1. Therefore, h1 r1 is equal to h2 r2. Therefore, we need to find the value of r, which is given as small r. Therefore, substituting the value h1 r1 is equal to h2 into 0.75 into r. Therefore, we know both the height as we know the height as 3.3 centimeters. Therefore, 3.3 centimeters into r will be equal to h2 into 0.75 r. R will get cancelled and the value will be become as h2 is equal to 3.3 upon 0.75. Surface tension of water is 7 into 10 is to minus 2 Newton per meter square, and its angle of contact with glass is 0. The rise of water in a capillary tube of diameter 0.5 millimeter is 10 centimeter, 8 centimeter, 5.7 centimeter, or 4 centimeter. Now we know that height or the rise of water is calculated by the formula H is equal to 2T upon R into rho into G. Therefore, on substituting values, we'll get as 2 into 7 into 10 raised to minus 2 upon R, which is given as 0.5 millimeters upon 2, since 0.5 is the radius, into rho, which is the density, into 10. Capillary tube, when immersed vertically in a liquid, records a rise of 3 centimeter. If the tube is immersed in the liquid at an angle of 60 degrees with the vertical, then the length of the liquid column along the tube will be A 3 centimeter, B 4 centimeter, C 5 centimeter, or D 6 centimeter. Now, to find the H dash or the rise in the water for the second time, is given by the edge, the height when the liquid rose for the first time upon the angle at which the liquid upon the angle in which the liquid is immersed, which is cos theta. Therefore, 3 upon cos 60 degrees, which is equal to 60, which is equal to 6 centimeter. Therefore, here the correct answer will be option D. Water rises up to a height of 4 centimeter in a capillary tube. The lower end of the capillary tube is at a depth of 8 centimeter below the water level. The mouth pressure required to blow an air bubble at the lower end of the capillary tube will be x centimeter of water, where x is equal to either 8 centimeter, 10 centimeter, 6 centimeter, or 12 centimeter. Now we know that water rises up to a height of 4 centimeter in the capillary tube. The lower end of the capillary tube is at a depth of 8 centimeter. Therefore, now in order to find the pressure at lower end will be equal to this 4 centimeter plus the 8 centimeter, which is equal to 12 centimeter of water. Therefore, 12 centimeter is the value of x which will be required to blow an air bubble at the lower end of the capillary. Therefore, the correct answer is option D. Water rises in a vertical capillary tube up to 10 centimeter. If the tube is made inclined to the liquid surface at 45 degrees, then the water will rise in the tube up to a length equal to either A 10 by root 2 centimeter, 10 root 2 centimeter, 10 centimeter, or 20 centimeter. Now, to find the height at which the water will rise when it is inclined at an angle of 45 degrees, we need to put the values in the formula. H is equal to the edge which the first time the water rises to the height, that edge upon sine theta, which is equal to h 10 upon 1 root 2, which is equal to 10 root 2 centimeter. Therefore, here the correct answer is option B. For tap water, clean glass, the angle of contact is 0 degrees, 90 degrees, 140 degrees, or 18 degrees. But we know that for theta is equal to 0 degrees only for the pure water and clean glass. Therefore, here the correct answer will be option A, which is 0 degrees. The height of a liquid in a fine capillary tube either increases with an increase in the density of a liquid, decreases with a decrease in the diameter of the tube, decreases with an increase in the surface tension, or increases as the effective value of acceleration due to gravity is decreased. Now, the height h is given by the formula h is equal to 2t cos theta t cos theta upon r into d into g. Therefore, we can say that h is directly proportional to t, h is inversely proportional to 1 by r, h is inversely proportional to the density, and h is inversely proportional to the gravitation or the acceleration due to gravity. So, in the first option A, the height increases with an increase in the density of the liquid, which is wrong. Since h is inversely proportional to d, if d will decrease, then h will increase. However, if d increases, h will decrease. Therefore, the first answer is not correct. Now, in the second answer, it decreases with a decrease in the diameter of the tube. Now, diameter or radius will be almost the same. So if the radius decreases, h will actually increase. However, here it is given that h also decreases, which is wrong. Therefore, option B is also not correct. In option C, height decreases with an increase in the surface tension. Now, h is directly proportional to t. So if t will increase, h will also increase. But here it is said that h decreases with an increase in the surface tension, which is wrong. Now, therefore, we are left with option D, which says h increases as the effective value of the acceleration due to gravity is decreased, which is actually true. Since h is inversely proportional to g, if g is decreased, h will increase. Therefore, the correct answer is option D. Water rises up to a height of 4 centimeter in a capillary tube immersed vertically in water. What will be the length of water column in the capillary tube if the tube is immersed in water at an angle of 60 degrees with the vertical? Is it either A 4 centimeters, B 6 centimeter, C 8 centimeter, or D 2 centimeter? Now to find the length will be given by the formula h upon cos theta. Therefore, h is 4 upon cos 60 degrees. Therefore, we get the answer as, since cos 60 degrees is 2, we'll get the answer as, since cos 60 degrees is actually half, we get the answer as 4 into 2, which is 8. Therefore, the correct answer here will be option C, 8 centimeters. Pure water rises through a height h in a capillary tube of internal radius r. If T is the surface tension of water, then the pressure difference between the water level in the container and the lowest point of the concave meniscus is either T upon R upon T, 2T upon R, or R upon 2T. Now, for a capillary rise, it is given by R into H into rho into G is equal to 2T cos theta. And the pressure difference is H into rho into G, which is dP. Therefore, dP is equal to H into rho into G, which is equal to 2T cos theta upon R. But for a water, theta is equal to 0, therefore cos theta is equal to 1. Therefore, dP is equal to 2T upon R. Therefore, the correct answer here will be option C. What is the force required to separate two glass plates of area 3 into 10 is to minus 2 meter square with a film of water of thickness 0.07 millimeter between them? Here, surface tension of water is given as 7 into 10 is to minus 2 Newton per meters. Is it either A 50 newtons, B 60 newtons, C 20 newtons, or D 80 newtons? Now we know that the work done is given by work done is equal to the force into D, which is equal to 2TA. Therefore, the force will be equal to 2Ta upon d, which on substituting of all the values, we'll get the answer as 16 newtons. Therefore, the correct answer will be option B. If the excess pressure inside a soap bubble of radius 5 millimeter is equal to the pressure of a water column of height 0.8 centimeter, then the surface tension of the soap solution will be, here are the options. Now, excessive pressure is given by 4T upon R, and hydrostatic pressure, H pressure, is given by H into mu into G. Therefore, since it is given as the pressure is equal to the hydrostatic pressure, therefore 4T upon R will be equal to H into mu into G. Therefore, we need to find the tension. Therefore, T is equal to H mu G R upon R. Therefore, on substituting the values of H mu G capital R and small r, we get the answer as 98 into 10 raised to minus 3 Newton per meter. Therefore, here the correct answer will be option C. Pressure inside a soap bubble A is 1.01 atmosphere and that in a soap bubble B is 1.02 atmosphere. What is the ratio of the volumes of A and B? Here are the options. Now, let P1 and P2 be the excessive pressure in the bubbles A and B. Then P1 is equal to 1.01 minus 1 is equal to 0.01 atmospheres. And P2 is equal to 1.02 minus 1, which is equal to 0.02 atmosphere. Now, because P is equal, that is the excessive pressure is equal to 4T upon R, therefore P1 upon P2 will be equal to R2 upon R1. Therefore, R2 upon R1 is equal to 0.01 upon 0.02, which is half. Therefore, R1 upon R2 will be equal to 2. And VA, volume of A upon volume of B, will be equal to R1 upon R2 the whole cube, which is equal to 2 upon 1 the whole cube, which is equal to 8. Therefore, here the correct answer will be option C, 8 is to 1. This is 8 is to 1. Water rises to a height of 20 millimeter in a capillary tube having cross-sectional area A. If the area of the cross-section of the tube is made A by 4, then water will rise to a height of 4 centimeter, 2 centimeter, 3 centimeter and 6 centimeter. Now H is inversely proportional to 1 to R. Therefore, we need to find the value of R in order to find the height, or in order to find how much the height will rise. Therefore, to find R, we'll first take area. Therefore, A2 upon A1 will be equal to R2 square upon R1 square. Since area is directly proportional to R square. Therefore, it is given that area is equal to A by 4. Therefore, A by 4 upon A will be equal to 1 upon 4 is equal to R2 square upon R1 square. Therefore, R2 upon R1 will be half. Therefore, R1 upon R2 will be 2. Therefore, in order to find the H2, which is the height, with which the water will rise, is equal to H1 R1 upon R2, which is 20 into 2, which is 40 millimeters, which is equal to 4 centimeters. Therefore, here the correct answer will be option A. Two small drops of mercury, each of radius r, coalesce to form a single drop. The ratio of the total surface energy before and after the change is. Here are the options. Now, first we need to find the relation between small r and capital R. Therefore, 2 into 4 by 3 pi r cube into d will be equal to 4 by 3 pi r cube d. Therefore, r cube, it will be 2r cube, which is therefore r is equal to 2 raised to 1 by 3 r. Now, because the energy is given by the tension into the area, therefore E1 upon E2 will be equal to 2 into 4 pi r square into t upon 4 pi r square t, which is equal to 2r square upon r square. Now we know the value of r as 2 raised to 1 by 3 r. So 2 into r square upon 2 raised to 1 by 3 r the whole square. So r square will get cancelled and we'll get the value as 2 raised to 1 by 3 is to 1. Therefore, here the correct answer will be option D.